Good morning. Today we're doing lesson 10.3, which is solving quadratic equations by graphing. Remember, a quadratic equation is ax squared plus bx plus c, just like we have here. Oftentimes it'll be equal to 0 or equal to y. We actually learned how to solve these or figure out where would this cross the x-axis if we were to graph our parabola. We figured this out back in chapter 9. We solved this by factoring using our diamond and our box. For example, multiplying our first and last term, and then getting our second or middle term down at the bottom here, and figuring out what multiplies to get this, but adds to get this, and then setting our two answers equal to 0 once we use our box. We're actually going to do the same thing today, but solve it by graphing. We're going to figure out where does this parabola cross the x-axis. So this answer would be x equals 1 and x equals 5, because those are the 2 points at which it crosses the x-axis. Or there are two solutions, and they are this and this. So let's take a look at our first equation. We have ax squared plus bx, not equal to, or not plus c, it's equal to c. So we need to get c on the other side, so I'm going to move it over so that we have our equation equal to 0 or equal to y. So we have 1/2 x squared plus 2x minus 6. So now a is 1/2 up front, b is 2, and c is a negative 6. If you forgot to move this over, you would have said it's positive, and that would make your answer incorrect later. So the first thing that we need to do in order to graph this is to find our axis of symmetry, negative b over 2a. This is the same procedure we followed yesterday on 10.2. So we have negative b, and b is 2, over 2a, and a is 1/2. So just think, half of 2 is 1, so x is equal to negative 2. That is our axis of symmetry, so at negative 2 right here, we're going to draw our dashed line. There's our axis of symmetry where our graph will fold in half or be symmetrical. Now once we have x, our vertex is going to be on that point, so I know x is negative 2. I need to find y. This is equal to 0 or equal to y, because we're finding when y is really 0 here. So we need to find what point is that. So we have 1/2 and then x squared, so negative 2 squared, plus 2 times x, which is again negative 2, and then minus 6. That'll give us y. So following our order of operations, I'm going to do exponents first. Negative 2 squared, or negative 2 times negative 2 makes a positive 4. And then 4 times 1/2, half of 4 is 2. Then 2 times negative 2 is negative 4, and then minus 6. So 2 minus 4 is negative 2. Negative 2 minus 6 is going to give us a negative 8. So y here is going to be a negative 8. Down 1, 2, 3, 4, 5, 6, 7, 8. There's our vertex. This is the same so far as we've done yesterday. The way we find our sides to our graph, our parabola, the arms, is we look for our point 0, c. Now some of you might be thinking, why are we looking for 0, c? Well, if I plug in a 0 for x, 0 squared times 0, that's 0. 0 times 2, that's 0. If we plug in a 0, we just have left over c, which is negative 6. So at 0, we have to plot the point negative 6. So 0, down 1, 2, 3, 4, 5, 6. And we're going to reflect c across our axis of symmetry. It's 2 squares away here, so go 2 on the other side, and there is c prime. This is where you have to draw your parabola. Now, I drew mine short for a minute here because we need to actually solve this. It doesn't just say graph it. we need to solve and figure out where is this graph going to cross the x-axis. So you need to draw your arms of your parabola right on up, make it a nice curve. Eventually they'll go vertical or almost straight up and down. But we need to figure out where do they cross this x-axis. Now mine crossed between kind of 1, 2, and 3. So what we need to do is simply guess and check. Is it more closer to 2 or more closer to 3? For the moment, I'm going to guess 3. See if that one works. So what this is telling me, this point right there, which is, let me look here, if we wanted to cross there, that point would be 0, 3. So if we plug in x is 0 for the x's, we should get out 3 for y. If not, that's not where our graph crosses the x-axis. So let's plug in a 3. We have 1/2 times 3 squared plus 2 times 3 minus 6. We need that to equal 0. Well, 3 squared is 9. Half of 9 is 4.5. 2 times 3 is 6. And then minus 6. 4.5 plus 6 is 10.5. 10.5 minus 6 is not going to get us to equal 0. So it's not going to cross there. Let's try the other side right here. That point would be 0, 2. So we know this one didn't work. Let's try the next point. Normally you only have to test 1 or 2 points and you'll figure it out. So if I plug in a 2 now, 1/2 times 2 squared plus 2 times 2 minus 6. We need to see, does that equal 0? Well, 2 squared is 4. Half of 4 is 2. 2 plus 2 is 4, and then minus 6. Well, 2 plus 4 is 6, and 6 minus 6 is 0. So this graph must cross at 2. So I'm going to kind of erase it a little bit and make it cross at 2. Right there. So I know this point, 0, 2, is where it crosses the x-axis, or when x is 2. Now, I don't have to guess on this side. I can just reflect over onto the other side. This is 1, 2, 3, 4 away from the axis of symmetry. So 1, 2, 3, 4. Oh, this one was way better. That one's already a nice point plotted. So we guessed and checked until we found the 2 points where it crosses the x-axis, at 2 and at negative 1, 2, 3, 4, 5, 6. Negative 6 and 2 would be our 2 answers. Let's try another one. This one will be a little bit easier, so stick with me here. We need it equal to 0, so I'm going to subtract 1 on both sides. Always write your x squareds, then your x's, then your number. And it's equal to 0 or equal to y. If you want to write out, a would be a negative 1. B is 2, and C is negative 1. So if we find our axis of symmetry, or when we have negative B over 2A, so negative B, so negative 2, over 2 times A, which is negative 1. That makes a negative 2 on the bottom. 2 negatives make a positive. 2 divided by 2 is 1. So at 1, I'm going to draw my axis of symmetry. My dashed line where my graph will fold in half. And then we need to figure out where's our vertex on that line. I know x is 1. I need to figure out what's y going to be. So let's plug this all into our equation. We have negative, and then, negative 1, and then x is also 1 squared. You don't need to include that first one, but if you want to, you can. Plus 2 times x, which is also 1, minus 1. That'll give us y. So 1 squared is 1. 1 times negative 1 is negative 1. 2 times 1 is 2. And then minus 1. Negative 1 plus 2 negative 1 plus 2 is going to give us positive 1, and I wrote 2. 1 minus 1 is going to give us 0. So our vertex is 1, 0. So if that's our vertex, we need to also plot C on here, our point 0, C, so we can reflect across the axis of symmetry. So the point we're going to plot is 0, negative 1, so 0, down 1, and reflect across to the other side, and draw your parabola down. Now this one, we need to figure out where does it cross the x-axis. Solve it. It's only crossing the x-axis in one point right there. It crosses that when x is 1. There's only one answer for this one, unlike the last one where we had 2 answers. If you have questions about that, let me know. But we actually plotted that point, so we don't need to guess. We know what the answer is. Alright, this one again, we don't have it equal to 0, so we need to move this 4x over to the other side. So we have x squared, then just our x's, so minus 4x, plus 7 equal to 0. So a in this equation would be a 1, b would be negative 4, and c is 7. So our axis of symmetry comes first, so we know where to start. Negative b over 2a. So negative b is already negative 4, so those two negatives make a positive. And then 2 times a in the bottom, and a is 1. So we have 4 over 2, which is really just 2. So our axis of symmetry is at 2, when x is 2. And then we need to plug that back in to find y, or our vertex. So we know we're going to have x is 2, we need to find y. So we have 2 squared minus 4 times 2 plus 7. That would give us y, or 0. 2 squared is 4. 4 times 2 is 8, so minus 8 plus 7 equal to y. So 4 minus 8 is negative 4. Negative 4 plus 7 should give us a positive 3. So right there is our vertex 2, 3. So 2 up, 1, 2, 3. And then last part here, we need to figure out what is our point that we're going to graph. 0, c. So c in here is 7, so we have the plot 0, 7 that we can reflect. So 0 up 1, 2, 3, 4, 5, 6, 7, and reflect it across, 2 on the other side. And there's our parabola. They asked us to solve this, to figure out where does it cross the x-axis. And you guys, it doesn't cross the x-axis. It's way up here. So this one, the answer would be that there is no real solution. Or just no solution. Either way, it's not going to touch the x-axis. So we just covered all 3 ways of how to solve a quadratic equation, or how many solutions are there. If it crosses in 2 spots, there are 2 solutions, or 2 x-intercepts. The graph could be going down the other way too. It could look like this, and there would still be 2 x-intercepts. If it has one solution, either going up or down, there's only one solution because there's only one spot that's on the x-axis. And last, no solution. This one was way up here. This one, if it's down here, doesn't matter where it's at. If it's not touching, there's no solution. So let's do one more just to see how many solutions there are, just to make sure we're all on the same page. A is going to be 1. B is also 1. Oops, not 1x, just 1. And then C is negative 6. So let's first find our axis of symmetry. X equals negative b over 2a. So we have negative 1 over 2 times a, which is also 1. So this is really just negative 1 over 2, or negative 1/2. So at 1/2, right in the middle there, between those two, draw your axis of symmetry. And then we need to plug it in to find our vertex. We know x is negative 1/2. So we have negative 1/2 squared plus negative 1/2 minus 6. Well, negative 1/2 squared is negative 1/2 times negative 1/2. So a negative times a negative makes a positive. 1 times 1 is 1, 2 times 2 is 4, or 1/4. If you want to write that as 0.25, you can. So if you have 0.25 minus here 1/2, or 0.5, and then minus 6, I'm just copying from up here. Positive quarter and a negative 50 cents, then you have a negative 25 cents. Minus 6, they're all negative, so negative 6.25. This is one where you could just plug this whole thing right here, right into your calculator. So we're going to plot the point at down 1, 2, 3, 4, 5, 6.25. That's our vertex. And then we need to plot 0, c. Where is our graph reflected on the other side? So at 0, we're going to be down negative 6. Because c is negative 6. So down 1, 2, 3, 4, 5, 6. Oh, you guys, this is the tiniest little graph here. Reflect that across. We have this little bitty tiny graph here. We need to, again, figure out where is it going to cross the x-axis. You could take this in a variety of different directions here. I want you to try your best to graph where it's going to be a nice gradual curve. So nice curve, a nice curve. That wasn't very straight. But then we need to test some points. Mine crosses really nicely at x equals 2 right here. So let's check to see if that works in our equation, to see if it equals 0. Because this is when y is at 0, x is 2. So we have 2 squared plus 2 minus 6. So 2 squared is 4. Plus 2 minus 6. 4 plus 2 is 6. And 6 minus 6 does equal 0. We're finding the zeros of the function or where it crosses the x-axis. So this one, I didn't even have to test another point. I know that works. And I'm 1, 2.5 away from the axis of symmetry. So a half, 1, 2. This one should cross at negative 1, 2, 3. So if you need to redo your graph here to ensure that it crosses at a negative 3, right here, that would be a good idea. There we go. So our two answers are x equals 2 because it's crossing the x-axis from the origin 1, 2, and from the origin negative 1, negative 2, negative 3. So those would be my two answers along with my graph. Last one like this, solve by graphing. This one, you guys, you need to be careful. We have ax squared, bx plus c. We have a and c. There is no middle term. There's no x's in this equation. So when we find our axis of symmetry, negative b over 2a, this graph, you guys, negative b, well, there is no b. This would just be 0. Our axis of symmetry is at when x is 0. This goes back to our first day of 10.1. So instead of finding our vertex, let's just make us a table, because this will help us find our vertex anyways. The reason why we're making a table and not plugging this in to find our vertex and everything else is because if we did, you just plug in 0 squared, that's 0, 0 plus 2 is 2. So your vertex is 0, 2, 1, 2. But there's not another point to reflect. 0, C. We already plotted that. There's nowhere to reflect it. So we need to figure out where do our arms go on either side. So we plugged in a 0. That was 0 squared. And then plus 2 is 2. We plotted that already. Then if we plug in a 1, 1 squared plus 2. 1 squared is 1. 1 plus 2 is 3. Same thing over here. Negative 1 squared is negative 1 times negative 1 makes a positive 1. Plus 2 is 3. And then 2. 2 squared is 4. 4 plus 2 is 6. So let's plot those points. At 0, we're up 2. We already plotted that one. At 1, we're up 1, 2, 3. And at 2, up 1, 2, 3, 4, 5, 6. And reflect those across to the other side as well. So this one is also no solution because it's never going to cross or touch the x-axis. So I know we went through that a little bit quick. Please feel free to go back, pause your video if you need to. Our last slide here just relates all of these together. All of these words really mean the same thing. Find the solutions, find the x-intercepts, find the zeros. It's all finding where does it cross the x-axis. What are the 2 points? Or the 1 point? Or does it even cross? That would be no solution. Alright, so here is your homework. I will have up on the board in a little bit some things you might want to add to your note card for your next test.